Section 10.6, we're going to learn about vertical asymptotes and holes. So warm-up is review. Can you simplify the following rational functions? So we know that when we have these rational functions, the first thing that we want to do is factor. So if we factor the first one, the numerator or the top of the fraction would be what multiplies to negative 24. That adds to 2 because there's a 1 in front of the x squared. We can use the guess and check. And the two numbers that multiply to negative 24 and add to 2 would be 6 and negative 4. And then the bottom, if you notice, it's difference of squares, two square numbers that are being subtracted, so that would give us x plus 4 and x minus 4. Once they're factored, we look for the ones and we cancel them. So if you notice, they both have the x minus 4 that we can cancel from top and bottom, and our final answer would be x plus 6 over x plus 4. For our second one, if you look at the top of the fraction, the numerator, all of the terms, there's 3 of them, and they each have an x in there. So let's divide out an x. So we're going to divide each by x and think about how many x's are left when we divide out the x. And we would be left with x squared plus 10x plus 21. Oopsies. And then on the bottom, we can divide, it looks like a 2x out of each of these. So we'll divide each by a 2x. And put what's left. And so 2x squared divided by 2x is an x. 14x divided by 2x is a 7. And if you notice, we can factor further. The x squared plus 10x plus 21, since it's just a 1x squared, it's what multiplies to 21. That adds to 10, and that would be 7 and 3. Oops. And don't forget about that x on the outside. So there's the top factored, and the bottom was that 2x, x plus 7. And now we look for ones and we cancel them, and they both have an x plus 7 on top and bottom. And they also, there's an x here that we can cancel out. And so when we write what's left, on the top we have the x plus 3, and on the bottom there is a 2. And there is our final answer. So we spent a few weeks looking at the simplifying fractions and also multiplying and dividing these rational functions and adding and subtracting. And so that's kind of the first half of the unit where we look at just the operations. So now we're going to take a look at parts of the graph. And we kind of started that in the previous lesson. Today we're going to go further and we're going to learn about an asymptote and a hole and how to find them. So first we'll start with an asymptote. Definition of an asymptote: it's a line that a curve approaches as it heads towards infinity. It approaches it, but it never touches it. So if you take a look at it, the curve is the blue line, the asymptote. It approaches that, it never touches it. You can kind of think of it like invisible fencing, right? You have a dog, it sees something it likes, it wants to cross the fence, but it knows it's going to get a shock if it does, so it doesn't cross it. So that's like your asymptote, an invisible boundary line that your graph approaches, but it never crosses. And there's 2 types of asymptotes we'll study in this unit, and one is a horizontal asymptote. So horizontal, think horizon. The horizon is flat, so the horizontal asymptote is the one that goes left and right. And the vertical asymptote is the one that goes up and down. And those are the 2 invisible lines that we're going to look at, and we're going to look at how to find them. So if you look at our function, here's our rational function. You can see the graph approaches that, but it doesn't cross it. Okay, so if we take a look at our parent function for this unit, 1 over x, here's what it looks like. There are 2 asymptotes right here that the line, if you look, the red lines never cross. The horizontal asymptote, and what color? I think it was green here, so I'll try to be consistent. So it's right here at x equals 0. This is the horizontal asymptote. Actually, it's not x equals 0, I'm sorry. It's the x-axis, but it's y equals 0, flat line. And the vertical asymptote is along this line at x equals 0. I'll say VA for vertical asymptote. And so it's always, if you have the function 1 over x, it's always at x equals 0 and y equals 0. That will be your asymptote, your 2 asymptotes for 1 over x. But our asymptotes shift if our graph shifts. So for example, let's talk about 1 over x minus 2. How does the minus 2 shift the graph? And we know that if it's in the parentheses with the x, it is left and right, and it's opposite of what you think. So this graph is shifting right 2. And what that does is it shifts everything right 2, including the asymptotes. Now notice the horizontal asymptote, if it shifts left or right, it's not really affected. So here our horizontal asymptote is still y equals 0 because it I mean, it can shift left or right, it's not going to move. But our horizontal asymptote, which was at y equals 0, is also going to shift right to. So if I shift it right to, the new equation of our vertical asymptote will be x equals positive 2. And then when we draw our function in, it looks like our mother function, but shifted. So if I sketch that, let's make it purple. It will approach the asymptotes, but never cross them. So it just shifted the whole graph over. So today we're going to look at shifts of the graph and how we shift the vertical and the horizontal asymptote as well. So in class we do an investigation. We would use a graphing calculator. In class I'll show you that. You can use Desmos as well. And so I'm going to show you both of these. It says using a graphing calculator, or if you use Desmos, the app or online, you can graph these. It says find the vertical asymptotes. All the while you should be thinking, why do they exist? How are they found? Just by looking at the function. And so the first one was 1 over x plus 2. Let's talk about the shift of the graph. This is left 2. You can make a prediction of the asymptotes. And we're just doing vertical today, but now I'll type it in. I'll do Desmos first, and I'll also show you on the graphing calculator. So if we go to Desmos, start graphing. I'm going to graph the parent function and keep that in, so it's 1 over x. Oops, I did I over x. Okay, so there's our parent function. We can see the horizontal asymptote at y equals 0, the vertical asymptote at x equals 0. So now I'm going to type in, I should do y equals, but I haven't. I guess it's fine. It works either way. All right, so let's do y equals, and let's do our first one, 1 over x, and it was plus 2. And you can see that the horizontal asymptote is still at 0, but the vertical asymptote would shift. It was at x equals 0, and now it would be, oh, I did 3, I'm sorry. And now it would be at x equals negative 2. You can see it doesn't cross that line, invisible line there. So in our notes, we can say that, okay, the asymptote, the vertical asymptote is now at x equals 2. Okay, so now make a prediction. Oh, we have 2 things here. What's going to happen? So we can try typing them in. Again, we can do it on our calculator. I'll show you on Desmos since that's what you guys have at home. All right, so I'm going to erase this function here. There's our parent function, and it's 1 over, and then I'll use parentheses because there's 2, x minus 3 and x plus 2. Now we can talk about the shift of the graph, and we'll talk about now, hey, look, there's 2 asymptotes, and one is at negative 2, and one is at positive 3. So let's write that down, and once we write all these down, we'll take a look at patterns. Okay, so the asymptotes, the vertical asymptotes, one is at x equals 3, and one is at x equals negative 2. All right, make a prediction. What do you think so we saw what it did for 1 and 2. What will it do for graph 3? If we have x plus 4, x plus 1, what do you think the asymptotes will be there? So again, I'll go to Desmos, and let's just adjust this one. So we have plus 4, and we have plus 1. Okay, take a look at the asymptotes. It looks like there's one at negative 4, and there's one at negative 1. So let's write those down. Negative 4 and negative 1. Okay, and then lastly we have 1 over x, x minus 5, and x plus 3. Make a prediction. We got 3 things here. Now what do you think the x will do? The x minus 5, x plus 3, make a prediction. And then we'll type it in here. All right, so I'll stick an x in front. And then it was x minus 5, and it was x plus 3. And if you take a look, I'm going to erase our parent function here. There is an asymptote at negative 3. Here's negative 3, at 0, and at positive 5. So there are all the asymptotes, the invisible lines. I'm going to write those down. Oops. Our vertical asymptotes are at positive, well, 0, I'll put 0, positive 5, and negative 3. All right, so question, how are the asymptotes found? Just by looking at the factored function. Well, if you look at the bottom, the asymptotes were what makes the bottom 0. Okay, so I wrote this one wrong, didn't I? So here, this should have been a negative 2. So if you notice, what makes x plus 2 0? Negative 2. What makes minus 3, x minus 3 is 0, positive 3. What makes x plus 2 0, negative 2. So it's just the zeros. The vertical asymptotes are the zeros. And for this one right here, what makes x a 0? Well, if it's just an x, it is 0. What makes x minus 5 0 is positive 5. What makes x plus 3 0? It's negative 3. So it's the zeros. It's finding the zeros, which we've done before. Finding the zeros of the bottom of the fraction. Okay, and we're looking at the factors of the bottom. Why do they exist? Well, what happens if you try to divide by 0? We've talked about that before. It's undefined, right? So if you have division by 0, if you have any number, we'll pick like 4, and divide by 0, that's undefined. So when it's undefined, it doesn't exist in the graph, and so that's why it's not in the graph, and there's those vertical asymptotes. So whatever makes the bottom 0, here 3 things make the bottom 0. If x is 0, 0 times anything is 0, and that is our first vertical asymptote. If x is 5, 5 minus 5 is 0, and then it doesn't matter what the other two numbers are because 0 times anything is 0. So then at 5, you have that vertical asymptote. And then what makes x plus 3 0? Negative 3. And that would make this whole thing 0. 0 times anything is 0, and that's why at negative 3 there's no graph there because it's undefined. So if you write that in our notes, why do vertical asymptotes exist? Because you cannot divide by 0. It's undefined. And so a vertical asymptote exists. Make a prediction. What are the vertical asymptotes of 1 over x minus 9 and x plus 8? Again, we would have to think, what makes this 0? What is the 0 of x minus 9? And that would be 9. What is the 0 of x plus 8? And that would be negative 8. And if you plug in either of these numbers, you get 1 over 0 on the bottom, and you have vertical asymptotes that exist because the graph can't be there. So this is the type of problem I might ask you to do in your assignment. What are the vertical asymptotes? And you would factor, and what makes the bottom 0. All right, so again, how do you find a vertical asymptote? Here are examples. Set the denominator equal to 0 and solve. This is like finding the bad spots in the domain. It's where the function cannot exist. It's undefined. All right, so here are the steps. First step, factor. You should hopefully be pretty good at factoring. So here it's what multiplies to negative 6, adds to negative 1. I'm thinking negative 3, positive 2. The bottom is difference of squares. That's x plus 1, x minus 1. All right, now we just look at the bottom. What makes the bottom 0? What are the zeros? So here are the vertical asymptotes. What makes x plus 1 equal 0? And that would be negative 1. So there's a vertical asymptote. What makes x minus 1 0? And that would be positive 1. 1 minus 1 is 0. So here are the 2 vertical asymptotes. So the vertical asymptotes, we're not really looking at the numerator, although we will in the next part. All right, let's just do one more example, and then we'll look at a hole in the graph. Okay, so you try. So first up, factor. The top is factored, but the bottom is what multiplies to negative 10 that adds to negative 3. Because it's just a 1 here, we can do that. And so you have x minus 3 on top, and I'm thinking 5 and 2. Multiply to negative 10, add to negative 3. Okay, so that works. All right, so when I say, what are the vertical asymptotes? Where does the graph not exist here? And we're finding the zeros. We've done that in the quadratic unit. So what's the 0 of the factor x minus 5? And hopefully you could tell me, well, that is 5. So x equals 5. And what's the other 0? What makes x plus 2 equal 0? And that would be negative 2. It's the opposite. So those are the 2 vertical asymptotes. All right, and then the last thing is sometimes there's a hole in a graph or a point of discontinuity, and that is when the numerator and the denominator are both zeros. All right, so it's actually the same steps as before. There's just one more part to that. Here are your steps, factor, just like we did before. But if there's the same factor in the top and the bottom, there's going to be a hole there because it cancels. So let's do an example. First step, factor. The top is already factored. The bottom, if we factor, it's what multiplies to 15 that adds to 8, and that would be 5 and 3. All right, so before, in the examples that we did, the top and the bottom, there's nothing that matched in the top, nothing canceled here. So we were able to go ahead and find the vertical asymptote, so it makes the bottom 0. But in this example, the x plus 5s, they would cancel. There would be a hole here. These would cancel, and we would be left with 1 over x plus 3. All right, so to find the hole then, the hole is what makes that 0. So the hole is going to be like the vertical asymptote at the 0, -5. So there's the first step. If they match, the hole is what makes it 0. So -5, it's the 0 of the factor. But we need the y value because to graph a point, we need x and y. We have the x. So the second step is we're going to plug in to our remaining equation after we cancel the x plus 5. We're going to plug in x equals, what is it, -5? Okay, so we're going to plug in -5 for x right there. So if we do that, it would be 1 over -5 plus 3, and that would be our y value. So y equals 1 over -5 plus 3 is -2, so -1/2. So in our graph, there will be a hole at this point, -5, -1/2. All right, and then let's look at what remains. There's a vertical asymptote. You look at the remaining thing on the bottom. The x plus 3 was the last thing on the bottom, so the vertical asymptote is the 0 of that. So at -3, there's a vertical asymptote. So let's take a look at what the graph would look like if we were to type this in. All right, you can see the vertical asymptote, this invisible boundary line at -3. It's an asymptote because the graph approaches it but never quite reaches it. So our vertical asymptote is x equals -3. There's a horizontal asymptote. This graph didn't shift left or right. So here, the horizontal asymptote is at y equals 0. You can see that again. Our function right here approaches that but never quite touches it. And then the new piece says there's a hole at -5, -1/2. This dot right here is our hole. And so we just show that with a little circle. Okay, so today you should feel comfortable doing the following. We've been factoring for a while, so 1 should be good factoring. You should be able to find the equations of the vertical asymptotes. It's just what makes the bottom 0. And then locating holes, which we'll review again, but that is if something cancels, what makes that 0, that's the x value, and then plug it in, and then find the y value. So I did include an answer key in today's assignment, but we probably should go over maybe a few of them, and then hopefully it will help you. Okay. So I'm going to look at, again, I showed the answer key in the notes, but let's do this one. Okay, so this is already factored. First, you would ask yourself, are there any holes? Is there anything that matches? And there are no holes. So here, there's no holes. So then we look at the remaining factor on the bottom to find the vertical asymptote. The vertical asymptote is what makes that 0, and that would be at x equals -2. So this would be your answer for number 5 on your assignments. Let's do one with a hole. Okay, so it looks like 7, there's a hole, and again, this is, you'll see it in the answer key. But let's erase and do the work. All right, so first step, factor if possible. And this one, the factor of the top, it's difference of squares, so that's x plus 2, x minus 2. And the bottom's already factored x plus 2. All right, this one, we have this thing that cancels. Like these would cancel, and that leaves us with 1 over x minus 2. So the whole, the x value is what makes the cancel part 0. So what makes this 0 right here? And that would be -2. So we know there's a hole at -2, but we need the y value of the hole. So that was step 1. Step 2, the y value is we're going to plug in 1 over, instead of the x right here, we're going to plug in the -2. So -2 minus 2, 1 over -4. So the hole is at the point -2, -1/4. And then we look at what's left over. Oh, actually, no, I didn't do that right. I'm sorry. So we have to look at what's canceled. It's just x. I'll do that. It's the x minus 2. All right, this was what was left over. I put 1 over x minus 2, and that was wrong, so I apologize. So it's just x minus 2 that's left over right here. So when I plugged in, this is what I'll have to change here. Okay, so x minus 2, we're going to plug in a -2 minus 2, which is -4. So I'm sorry, the whole should be at -2, -4, not -1/4. And then in this left over right here, there's nothing on the bottom of the fraction, so the only vertical asymptote here would be at 0 because there's nothing on the bottom, and if you have a 0 on the bottom, you would have your vertical asymptote there. All right, so I tried to explain in the answer key, I showed the work, like how to find the holes and plug in. So if you have questions, you can see that. Also visit me in my office hours and we can go over more if you have questions on vertical asymptotes and holes.